Hey guys, it's Miss Johnson and I'm here to bring you our lesson video for Unit 4 Learning Target 1. Today we are kicking off Unit 4, which is our unit on quadratics. Quadratic is kind of a funny word that you probably haven't heard too much before, but all of Unit 4 is going to deal with quadratic equations. So far in intermediate algebra concepts, we've been talking about linear equations, where we've got x to the first power. In Unit 4, we're getting into quadratic equations, which is x to the second power. So you're going to start seeing a lot more equations with x to the second power. Today, we're just starting off simple with what's called the zero product property. It sounds complicated. It's really not. It's really not. It's a really simple concept that allows us to solve a quadratic equation. So let's just think back. If we think back to Unit 3 when we looked at some factoring stuff, we had trinomials that looked like this. We had x squared. In number 1, we have x squared plus 6x plus 8. And let's say we wanted to factor this. If I wanted to put this in its factored form, I would set up a factor x. I'd do a times c on the top, so 1 times 8 gives me 8. And then on the bottom, I'd have the middle term of 6. And two numbers that give me a product of 8 and a sum of 6 are 4 and 2. So when I go through and factor those, I split up the 6. So that gives me x squared plus 4x plus 2x, and then keep plus 8 at the end. I would stick those in a box, x squared, 4x, just to keep them organized. It's a nice way to keep them organized, to put them in a box like this. And then I would pull out the GCF. So for the top row, the GCF of x squared and 4x is an x. For the second row, the GCF of 2x and 8 is a 2. For the first column, the GCF of x squared and 2x is an x, and the GCF of 4x and 8 is a 4. These are all positive, so those would be plus, and my factored form would look like x plus 2 and x plus 4 for my two factors. Okay. Let's take a look at number 2 and practice that one. So in number 2, I'd set up my factor x. I'm going to write yellow in this blue area here. So 2 times 15 gives me 30, and then my middle term is an 11. So two numbers that multiply to 30 and add to 11 are 5 and 6. So that's what I'm going to split that 11 into. I'd have 2x squared plus 5x plus 6x plus 15 from that last term. So then I put those things in a box, 2x squared, 5x, 6x, and 15. And I look for those GCFs. On the top row, 2x squared and 5x have a GCF of x. In the second row, 6x and 15 have a GCF of 3. I can divide 3 out of both 6 and 15. From the first column, 2x squared and 6x, I can take out a 2 and an x. And from the second column, I have 5x and 15, so I can divide out a 5. So I have one factor of x plus 3 and another factor of 2x plus 5. That's my factored form. Okay, so now here's where factoring comes into play. When we have these factored expressions, we can use the zero product property to solve them. So here's what the zero product property says. We have if a times b is equal to 0, then either a equals 0 or b equals 0. Okay, so if I have two things times b equaling 0, it's like I can split them into a equaling 0 and b equaling 0. And that's what we're going to do with these factors. So to use the zero product property, the zero product property comes in handy for us, because to use that, I'm going to take each factor and I'm going to separately set it equal to 0, and then I'm going to solve that. And that's going to give me my answers to my quadratic equation. Here's what we need to remember, or here's what you need to know about quadratic equations. Quadratic equations have a possibility of two solutions. Okay, they don't always have two solutions, but a lot of times you'll find two different solutions. It's where that x squared comes into play. So all of our trinomials that we were just working with, like the one we just had, which was x squared plus 6x plus 8, this square right here tells you that there's a possibility of two solutions. So since there's a possibility of two solutions, that's where we can set each factor equal to 0 and solve and get two possible solutions. All right, so now we're going to do a couple examples of this zero product property, but these are already going to be factored for us. So that first step of factoring the trinomial is already done, which helps us a lot because it just makes our life a little simpler. It's already in that factored form. So I have the factored expression, the quantity x plus 6 times the quantity x minus 4 is equal to 0. Here's the kicker. We did not have any equal signs in Unit 3. When we were going through all that factoring stuff, we weren't setting things equal to 0 and solving it all. We weren't doing anything that involved solving. We were just factoring. Now, when you see equals 0, that means that we need to solve this. Okay, solve for x. That, in other words, we're going to try and get x by itself. Now, in this case, you have two different factors that could each equal 0. The zero product property tells me that I can split these two things apart, and I end up with x plus 6 equaling 0 and x minus 4 equaling 0. That's what the zero product property allows me to do. So since I can set these two things apart, now I just solve them separately. Over here, I would subtract 6 to get this plus 6 away from the x, and I'd have x equals 0 minus 6, which is negative 6. On the right-hand side, I would add 4 to cancel that 4, but I got to add 4 to the right as well. 0 plus 4 gives me 4. So my two solutions, notice how I write this. I write them as x equals negative 6 comma 4. It's like making a list. It's like making a grocery list. You write something down, write a comma. Write it down, write your next thing down, write a comma, okay? You're separating out your solutions with a comma. Now, is it wrong to just box the solutions separately? No, not at all. You could totally box those two solutions individually and move on. I can promise you that this is how you would see it if it were an ACT or something of that sort. Okay, let's try number 4. So again, I see that I have the factored expression x minus 4 times the quantity x plus 2 is equal to 0. So since this says equal to 0, I'm going to solve. Okay, so that means I've got x minus 4 equals 0 and x plus 2 equals 0. Okay, now I get the x variable by itself on both sides. So I have over here, I have to cancel that subtraction of 4, which means I'm going to add 4. And that gives me 0 plus 4, which is 4. And then over here, I'm going to subtract 2, which gives me 0 minus 2, which is negative 2. So my solutions are x equals 4 comma negative 2. Now, some of you may ask, does it matter if you do x equals negative 2 comma 4? Well, if you're going to the grocery store, does it matter if you list cucumbers and then carrots or carrots and then cucumbers? No, it doesn't make a difference. They're just all in the list. So it doesn't matter what order you list them in. Either one of these would work. You could even box the two up individually and it would work that way as well. Let's try the next two. So in number 5, I have the quantity x plus 5 times the quantity x plus 12 is equal to 0. So again, I notice that I have things set equal to 0. That tells me I'm going to split them and solve them. So I have x plus 5 equals 0 and x plus 12 equals 0. On the left-hand side, I need to subtract the 5. So I get x equals negative 5. On the right-hand side, I need to subtract the 12, and I get x equals negative 12. So down here, I have x equals negative 5, comma, negative 12. In number 6, again, I have two factors. Notice that these, again, are all factored form already. They're already in the factored form where they're in two sets of parentheses. So 2x plus 6 is one of your factors. 3x minus 9 is another factor. Here's your equals 0, which tells you to solve it. So I'm going to split them apart. 2x plus 6 equals 0. Sorry, that was supposed to be a line. 3x minus 9 equals 0. Over here, I'll start on the left. I'm going to subtract 6. So that goes away. That leaves me with 2x equals negative 6. Then I need to divide by 2. This is a two-step equation here. So then I divide by 2 and I get x equals negative 3. Okay. On the right-hand side, I'm going to add 9. So that goes away. I have 3x equals 9. Divide by 3, and I end up with x equals 3. So I've got solutions of -3 and +3. And yes, those are two different things. All right, a couple more examples that we're going to look at here. Again, these are all in factored form today. So I've got 2x minus 3 as one of my factors and x plus 1 as another one of my factors. Here's my equals 0, which tells me I'm in the business of solving it today. So take these two, split them apart. 2x minus 3 equals 0, x plus 1 equals 0. So add your 3. I get 2x equals 3 and divide by 2. Now here's the thing, 3 over 2 does not simplify well. You could call it 1.5 if you wanted to, but really you can just leave it. If your fraction doesn't divide anymore or reduce anymore, then just leave it. You don't have to do anything with it. On the right, I'm going to subtract the 1, and I get x equals -1, and that's all I need. So my solutions are x equals 3/2 and -1. One more example that we're going to look at today. So I have 5x plus 4 times the quantity x minus 2. Here's my equals 0, which tells me I'm solving. When you don't see that equals 0, you don't actually need to solve. It's just when you see the equals 0 that now you are in the business of getting x by itself. So I've got 5x plus 4 equals 0 and x minus 2 equals 0. On the left, I'll start over there. I'm going to subtract 4. I get 5x equals -4. Divide by 5. And again, -4/5 doesn't reduce very well. So I'm just going to leave it like that. Over here, add your 2. And I get x equals 0 plus 2, which is 2. So my solutions are -4/5 and +2. There you have it. That brings us to the end of our lesson for today. So thanks for tuning in, and I will catch you next time.